Okay, so now let's get started. And so we will look at there's one important idea which will be useful, which comes in very handy to you. I just want to open one book. Yeah, I will share my screen again. Okay, so I want to open something. So due to that, I unshared my screen. All right. So yeah, the topic for discussion, the first topic for discussion today is this logical operators. Okay, so like for example, if you have a statement expression A equal to B, so where A and B are variables, then what it means is this will return to true. This will return, there are two possibilities. If A is actually equal to B, the contents of variable is actually equal to B, then they are equal, then you get two answers, either yes or you get true or false. Okay, remember in C, true is, there is nothing like true or false. True is represented as a positive integer, not positive, as a non-zero integer, and false is 0. And when we put the negation, so A equal to B, then what happens is if A is equal to B, then this will evaluates to true, this evaluates to true, and negation of true is it becomes false. It becomes false. So in other words, if you, let's say, let me clear the screen. So let's do one thing. So if A equal to, this is a statement, this is A. So this is, let's say if A is 10 and B is 5, then what is the, so this is the expression tree associated with the statement A equal to B. This is the expression tree associated with the statement A equal to B. A double equal, comparison operation, whether A is equal to B, that's the comparison operation. If A contains value 10 and B contains 5, then the value of this node is true. And the value of this expression is true. True is some non-zero value. On the contrary, if A is equal to 0 and B is equal to 0, what is the output? What is the value of the expression? If A is equal to 0 and B is equal to 0, what is the value of the expression? The value of the expression, so many times it gives, it is true, and you get value 1, but we cannot rely on 1, it depends on implementation. All you can say is it's a non-zero value, but it is a true. But if we have, let's say, so now, so let's take an alternate expression. I'll draw it here itself. So the alternate expression we have is we are looking at negation of A equal to B. Then what happens is this picture is not clear. Let me draw here. So we will have, this is negation. So negation, it's a unary operator, equal to A or B. See rhythm. So when we compare two things, either you get a true or false, but the representation of true in C is in any non-zero value, 1 or any non-zero value. That means it is true. 0 means it's false. So now in this case, let's say if A is equal to 10 and B is equal to 5, then this A equal to, so 10 is not equal to 5, this evaluates to false. I am writing as false, but it is 0, and then negation of false is true. Okay, negation of false is true. So this is how this is case 1. So this will be useful for you in some cases, okay, using negation operator. And let's take one more example. If this is equal to 0, this is equal to 0, both of them are equal to 0. So this node evaluates to true and this node evaluates to false. So 0, 0, true, false. That is a convention, Harsh. It's just that no, in our world, negative, positive, non-zero value is it's just we treat it as true. That's all. In programming, it's all convention, right? In language, it's just convention that we follow. And we just have to stick to that convention consistently. That's all. Are you with me in the negation operation? And the next two statements, I want you to pay one attempt, I want you to think about one, do an experiment later. Is both these statements the same? Or both these, sorry, this is homework problem, okay? These are the kind of problems I may ask in the exam, okay? So negation of A equal to B and no negation of A equal to B, whole brackets, are they the same, equivalent? This is check, okay? So some of you might be knowing, some of you may not be knowing, but make a note of it. Make a note of it and work. Excellent, Ujjwal. So work on it, figure it out. So now we want to look at, this is called as a Boolean NOT or negation operation. And we will look at Boolean AND and Boolean OR operations now. All right. So it's not left associativity, Manoj. Yeah. So let's say if there is, you want to check whether an integer lies between, so you want to check this condition, 2 is less than or equal to 9. Okay. So why? So like, for example, in the histogram problem, let's do this. So you want to check in the histogram problem whether a given mark lies between 10 is less than or equal to, no, mark is less than 19. So let me not, this is not a mathematical thing. So less than or equal to. This is the mathematical condition. In last year, when I saw code for many students, they made a mistake. They take this mathematical thing and just write it like this. And no, they struggle and see what is happening. And this doesn't work. This is wrong, and I will tell you why it doesn't work. But the right way to express is 10 less than or equal to mark. Okay, put and then mark less than 90. Again, whether we need to have parentheses, no, counting, put, so gave this thing. So I again want to check, okay. So an alternate way of writing this is, without parenthesis. So whether both are the same, whether this one and this one, whether 1 and 2 are equivalent, this is AND operation. This is like AND. This is AND. Okay, so whether they are both the same or not, you have to check. But let's stick to make a note of the questions I am asking you. And those of you who are confident, you are good, but otherwise, others, I request you to check on your thing on your own. How do you check? You read the book, number 1. Number 2, you write a program and check. Okay, that's how you work things out. You read the book and then you double confirm by writing the program. That's the best. All right. And what is the expression tree? So for the time being, we will focus our attention on only one. So this is an AND operation. That is, this whole Boolean expression is true only if the left-hand side is true and right-hand side is true. But I agree with Chaitanya that it is better to have parentheses. So that's why I'm using parentheses. So 10 mark and then again less. So this is the expression tree associated with this. So what happens is if mark is equal to 4, let's say I'm using a different color. So if marks are equal to 4, 10 less than or equal to 4, it is false, right? So the interesting thing is this evaluation happens from left to right. So if this is false, you don't need to check the other condition, right? Yes or no? Because we want both the things to be true. And if you know the left one is wrong, then you don't need to evaluate right. This is what is called as a short circuit evaluation. Short circuit evaluation. Great. So that's it. So go. No, but on the contrary, let's say marks are equal to 20. Okay, if you take marks as 20, then what happens? 10 is less than or equal to 20. Yes, this evaluates to true. And then again, we go here, 20 is less than or equal to 19. This evaluates to false. True ANDed with false, it is false. So the value of this expression is false. Are you with me here? Yes. So now, let's take a value which lies between 10 and 19 and see how it works. So let's say the value of mark is 15. So this is 15. 10 is less than or equal to 15, true. 15 is less than or equal less than 19, true. True ANDed with true, true. The value of the whole Boolean expression is true. So this is how the AND statement works. All right. So now there is this. I hope you're all with me on this one. There is this question, why is this box statement false? This, to start with, there is nothing like this symbol in the C. No? You cannot write this in the C program. You cannot type this in the editor. Okay. So yeah, you can type it in, but it's not going to work because that symbol is not even a valid character in the C programming language. That less than or equal to symbol, which you are seeing in the box. But what you can write is, this is what students wrote in the last year, some of your seniors, 10 less than or equal to mark. So what happens is, the way this gets translated into an expression tree, but this is a valid expression. So this is a valid expression. So what happens is this gets translated to less than 19, less than or equal to 10 mark. So what happens is if mark is equal to 4, let's assume the value of mark is equal to 4. then 10 less than or equal to 4 is false, and false is, the value of false is 0. 0 is less than 19, so you get this as true. Are you with me? Do you see what is happening here? So the compiler doesn't give error, it's a logical error. This is not a syntax error. That's the thing I want you to remember. This is a semantic error. This is a logic error, and the compiler will not be able to do anything about it. See how mark being 4 still is satisfying. Okay, so that's the problem. But on the contrary, let's say mark is equal to, let's take a different value. I will use a different color for a different value. Let's say I will use mark as 15. See what happens for 15. Is 10 less than or equal to 15? It is true. And the true is 1. And 1 less than or equal to 19 is true. So you get true. But the problem is this true being equal to 1, it is not guaranteed. It depends on compiler and implementation. So instead of this being 1, if this is, like 100, then 100 less than 19, it becomes false. So in some people's, on some people's machines, it will work. On some other people's machines, it doesn't work. And so, depending upon the compiler and other related things, so you get into trouble. You see the point? For the same 15, it can evaluate either true or false, depending upon whether the true is, equal to 1 or some other thing. So this translation is wrong. This is not a, this is wrong. So this is the reason this is wrong. You cannot do this. So you have to use you have to divide this condition into 2 as we did before and express it as an AND operation. All right. Are you all with me here? Shall I move on to the next problem? Next idea. Okay. So the next idea is the OR operation. This. So which is this? So logical or the operator for it is 2 vertical bars. So let's say you want to check the condition. So let's see. So let's say you want to check whether a number. So you want to check. Question is check whether a number is divisible by 2 or 3. This is the problem. So what the condition we write is A, the remainder, in order to check whether A is divisible by 2, we take the remainder A%2, whether A%2 is equal to 0, or we use this vertical bar, or we check if A%3 is equal to 0. So this is the condition that we use to check whether one of these 2 conditions are true. So if you write it in an expression in this form, so you have equal to operator 0% A2. This is one side of the tree. So whenever you get a doubt, you should write down these expression trees. These expression trees are very useful. So do you understand this expression tree? Does it make sense? This expression tree that we have written, the mapping between this and this, does it make sense for you? Now let's say if you take the value of A is equal to 4, if A is equal to 4, then 4% 2, that is remainder is 0, and 0 compared with 0 is equal to true. And since it is equal to true and this is an OR operator, you don't need to evaluate the right side expression tree. You just will stop here. And again, we are using this idea of short circuit evaluation. If it is true, you don't need to evaluate the second part. You can't see the whole tree, or is it? I don't have any scroll bar. Really? Huh. Something weird. Usual stuff. Now you can see? Okay. Weird. So I share the whole desktop and I don't see the reason why it shouldn't. So now you can see when A is equal to 4, how both, you don't need to evaluate the right side expression. Okay, so great. But on the contrary, let's say A is equal to 3. Let's try this. If A is equal to if A is equal to 3, 3% 2, that is 1, that is remainder, 1 equal to 0, it is false. So you have to go here, but 3% 3, it is 0. 0 is equal to 0, true. False odd with true, it is true. So if one of the two subtrees are true, evaluate to true, then the whole tree evaluates to true. So this is how logical OR works. Okay. So this is about logical expressions. You have to use them. If you use, you can use them cleverly to write many programs. Nice. Great. Any questions here? If you don't have any questions, we will move on to the next set of ideas. Okay, great. I think you're all doing awesome. So now, so yesterday, we looked at the for loop. So let's open that file. Hmm. 2D array.c. You remember this program? So we are reading a matrix and we are printing a matrix. That's all we are doing. What is section B folder? Okay. So, yeah. So we see two loops. And so yesterday, yesterday or day before yesterday, in section B, I got some interesting idea to explain for loop. So I thought we will revisit this for loop. Okay, so if you think of this for loop, if you have a matrix of size, that's I see. Okay, let me do one thing. Thank you. Yeah, same, but okay, still good. Thank you, Amoga. Thank you, Shivam. So, and the problem set that I gave is I got inspiration from the discussion. So here we have a 2D matrix, okay? And you can think of your 2D matrix as, so as some kind of, let's say we are looking at a 3x3 matrix. And how do we traverse this matrix? Okay, in order to understand traversing this matrix, so the analogy that we thought of is, so we take an elevator, okay, we take an elevator which starts in ground floor. It starts in ground floor, and then you visit all the rooms in the ground floor. How do you visit all the rooms in the ground floor? By using the inner loop. Okay, so this is floor 0, floor 1, floor 0, floor 1, floor 2. Yeah, it is bad because it is looking inverted, but you get the idea. Okay, so floor 0, floor 1, floor 2, and then you think of this, each of these things, on floor 0 there are 3 rooms. So you stop your elevator on floor 0, and yeah, you can think of basement and -1, -2 you'll get, and then anyway get into trouble. But yeah, so but you get the idea. You start on floor 0. How do you start on floor 0? So like, for example, we can rewrite the code. Like instead of I, so you start in floor 0, and you don't, in terms of visually speaking, I drew the picture in this way because this is important with respect to memory layout. Okay, so you start in floor 0, and once in floor 0, what do? You visit different rooms. Yeah, you visit different rooms within the same. Floor is allowed as a variable. Why not? Okay. So I have to modify this code also, but we are not compiling the program. But now, do you understand what we are trying to do? We on floor 0. We start on floor 0, and then we visit all the rooms within floor 0. We go to floor 1. We visit all the rooms within floor 1. How do you visit the rooms? You visit the rooms using inner for loop or outer for loop? Visiting the rooms. We visit the rooms using inner for, and we visit the floors using outer for. So now, what is that? Oh, sorry. Oh, got it. I got the confused. Sorry, guys. Yeah, so if you want, maybe, we are talking about, if you just think of, we are thinking of this of a hotel, then thank you. You're all very helpful to me to fix all the bugs. Now, is it all good? The reading part, the read matrix part. Yeah, from 8 to 26, I'll, yeah, let's say for the sake of So keep this example in mind. So when you are, when you get confused, keep this example in mind. And then there is this question, how do we think of 3D loops? You know, in the 3D, we can have 2D array, 3D array. When we have a 3D array, so the third dimension is different beds in your room, each room, let's say cubicles in the room, okay, cubicles or beds in a dorm room. So you can extend that dimension like that. And if you want to have a fourth dimension, what do we do? So third dimension is beds in a room. So let's say floor. So floor, and then you go to rooms in the floor. Yeah, double decker, bunk beds. Exactly. Beds in the room. And then like that, you can fourth dimension, whatever. Okay, so keep this analogy in mind whenever you get confused. So Shreya will talk about memory allocation for arrays later, but for this class, this is good enough. Great. Okay. Yeah, continents, countries, states, cities, awesome. Yeah, good. All examples good. So now we will see one how to use functions. See, there is this request from Harsh saying, no, after completing the code, can we please put it in the chat? So don't follow along now. I want you to watch the video later and type it in. The reason why I want you to type it in is, as beginner programmers, it's good to type it in by yourselves. It will be helpful. So when I am learning a new language, no, I kind of take a book, and although the code for those programs are available online, I still type them in so that I remember some syntax. So as beginners, yeah, so you refer to the recording. Don't type it in now. You look at the recording later and type it in. It's important that you type the programs. Sounds dumb, mere typing, but still, I feel it has some value. Okay. So now we will talk about, or take a screenshots. Print screen. Okay, I have a very interesting question for you. Take screenshot of the code versus pasting code in the chat box. What's the difference? Can't copy. Yeah. Indentation won't be correct. No. When you take a screenshot, what is the representation of the screenshot? It is pixels. It is JPEG. It's an image. So you know that it is a program, but but from the computer perspective, it is just an image. So the representation is pixels. The representation is pixels. But if you cut, copy, paste the code in the chat box, what is the representation of it? It's a series of ASCII characters. Every character has an 8-bit encoding. It's a series of ASCII characters. You just copy it into an editor and it works. Okay. Okay. So now I want to, let's see, use some program that we have written before. Some array.c here. Okay, doesn't matter. I can write it from the scratch. So now our goal is we want to compute sigma I is equal to 1 to n I square. This is what we want to compute without using the formula that you learned in intermediate. Okay, so that's the goal. All right. So what do we do? So yeah, so we write this. So we want to write modular code. Okay, we want to write modular code. So far, and our thing, the way we do scanf %d ampersand n. Okay, this is looking good. So now what we want to do is, so we want to write a loop. This is what we do, right? Int I is equal to 1, I less than or equal to n, plus I. Plus I is just increment I, and sum is equal to sum plus. I want to now make the code modular. So I say I want to write a function called square I. So main is one function. So now we want to write one more function called as sum. This sum function, the signature of the sum function is as follows. Sorry, the signature of the square function is as follows. It takes an integer, okay, it takes an integer, int whatever I or whatever it may be, int a, let's call it as a, and it returns a integer, okay, and so it will say int sq squared underscore value, squared underscore value is equal to a star a, and we return so now we have written our first function. What is the semantics of our, what is the syntax of the function? The syntax of the function, there is a function identifier, name of the function is there, followed by that list of parameters in parenthesis. This is list of parameters in parenthesis. And then before square, we have the return type, the value returned by that function. And then the body of the function is enclosed using the flower brackets on line number 3 on line number 9. And within these flower brackets, we have the body of the function. We are declaring a variable called as squared underscore value. The scope of this variable is within this function. That means other functions will not be able to see the squared underscore value variable. And here the scope of this is what is called as a parameter A. The scope of parameter A is also within the square function. And we are saying squared underscore value is equal to A star A. And then finally, we are saying return squared underscore value. Are you all with me on this code? So here, this is a function which returns an integer. So we are having this return squared underscore value. I hope all of you are with me. Those of you who didn't look at functions before, you are also able to understand. We can return 0, 1. So when we call square A function, so there is this nice question, the parameter A is not initialized. But when you call the function square with I, the parameter A will be initialized with the value of the variable I that we are using here. Okay, the parameter A is initialized with the value of the function of the parameter I that we are using here. So here, this is a very important idea. So this is what is called as a function definition. This is what is called as a function definition. And this is what is called as a function call. We are calling the function. When you define the function is not active. Only when you call the function becomes active and the instructions of that function are executed. Yes. Square function is not there like printf in any library. So because of that, we are defining the function by ourselves. We are defining the function square. So first, we are defining the function square. How many parameters the square function is taking? I'll ask a series of questions. 1. What is the type of the parameter? What is the name of the parameter? What is the value returned by the function? What is the scope of the parameter A? Scope means the chunk of code square. We can use parameter A only within square. And squared underscore value, it's a local variable. It is what is called as a variable. So A and square, these are called as local variables. Variables which are local to the function square. Similarly here, n and sum, these are also local variables. These are also local variables. So we are computing, so is a function square active when we define it? It is not active. It gets active only when we call it. And how is the variable A initialized? When we make a function call, in this particular case, after we make a function call, the value of I will be passed to. Yes. So this is our square function. It takes as input a parameter A and it returns whatever the squared value. This is what is happening. No, hash defined doesn't create global variables. Is it possible to write the function? A function is always defined outside the main function. It's not defined inside another function. Your C program is a list of functions. So in this list, this is your first function. Square is the first function. Main is the second function. So now let's compile this program. Let's compile this program and run. And let's see if I can use my debugger. Is it working? Okay, let's see. I didn't set my machine. Restart the. Okay. Are you able to see the screen? So I'm entering the value of n as 3. Okay, I didn't set my debugger properly. Let's see if I can. It should work. Yeah, printf sum is there. I want to show today, maybe if it doesn't work, I'll fix it later. And it seems to be working. So step over. So now are you all able to see the screen, my screen now, the VS Code? And now we are debugging the program. Why all my drawings? Yeah. So now we are debugging the program using in the Visual Studio Code. Okay. So now if I enter the value of n, let's say as 3. Yeah. So I want you to pay attention on the screen on the right side. You can see the debugger is showing the value of the variable n is equal to 3, the value of sum is equal to 0, and I is not yet initialized, so it is holding some value. So let's step over. When you step over, we are on line 19 now. Are you all with me? We are on line 19. You can see this triangle, this mark on line 19. At the beginning of line 19, you see the mark indicating we are there. So now, when we are in line 19, so we are calling the function square. What is the value of I? We are calling the function square with I equal to 1 as parameter. So now we are stepping into here. So now we entered the square function and you can see here below what is called as a call stack. That is in function main on line number 19, we are calling the square function. And now we are inside the square function. And what is the current value of squared underscore value? It is some garbage value. And A is also some garbage value. But now, after when we step over, you will see that the value of the parameter A is changed to 1. Now, A times A is equal to 1. Okay, so now squared value is also equal to 1. And then after that, if we do step over, we come back and we are back to the main function. Are you all with me here? And you can see that the value of sum at this point is equal to 1. Let's continue this process. So see, the value of I is equal to 1. And if I step over, the value of I becomes equal to 2. And now we step into the function. When we step into, we enter the square function. Look at the call stack. The call stack says that we are calling main with square as we are calling square function from main on line number 19. Go over, you will see that the value of A is equal to 2. Okay, 2 times, now after that 2 times 2 is 4. 4 gets returned. And so now you can see that the value of sum is 1 plus 4, which is 5, so on and so forth. So what is the cool thing in this approach is when you debug using Visual Studio Code, you can see what is happening on the right side as you step through. You don't need to explicitly print the variables and all. You can, you can have a similar thing using the TUI interface, this text user interface, but still this is more clean. Okay. And there is this question, sir, we are not printing sum, but I want to see what sum is by looking at the through GDB. Okay. So now what I did is I just stepped over. Yeah, we can do breakpoint. Now anywhere you go to any line, you get this red dot and you press, you click your mouse there. That's the breakpoint. Very simple. So there is a question, why am I returning this? Because we want to compute the sum of square root numbers now. That's the reason we are in order to compute the square of this, we are saying square I. Don't worry about register section for the time being. Are you all with me on this example? Yes, no? You want me to use text to GDB and show what is happening? Or this is good? So now, so you're all good. So now you are, you can write functions, arrays, you can write functions, and I have one question. So there's one more idea I want to introduce. If you're up, if you feel enough of stuff, then I will stop. But otherwise, I can take some 5-6 minutes more and talk about it. But that's a very deep idea. It requires. Okay, 11:15. I will have a hard stop. Okay, so this idea here is when we are copying, the most important thing is. So the most important thing here is the memory for the variable I here and the memory for the variable A in square, they are different. They don't have, they are completely different. So what happens is when we call square I, the value of I is copied into the memory associated with the variable A. Are you with me here? So let's say this is an important idea, very important idea actually. The very important idea is in your program, this is your RAM. This is your RAM. So this is the memory for main. In this memory for the function main, somewhere the memory for the variable I is allocated. Okay, this is for variable I. And when square gets invoked, square, the memory for this is the, I'm presenting a simplified picture. Later I will provide a more involved picture. So the memory for square is here, and within square the memory for variable A is here. So when we call square on line number 19, if I contains 20, then 20 gets copied into, and 20 gets copied here. And then square will carry on its execution. So the memory for variable I and the memory for variable A, they are independent of each other. They don't, they don't have any relationship. In fact, you may call square again from some other place, and totally different. You may pass the parameter value using a different variable altogether. All this is possible. This particular mechanism of parameter passing, so this is what is called as a parameter passing mechanism. Parameter passing mechanism. This particular way of passing parameter passing mechanism is what is called as a call by value. Okay, you pass the value, Okay. So this idea you have to remember that you are passing a parameter by value is very, very fundamental. So any changes to variable a here in this square function, it is not going to affect the variable I at all. There is no link between variable I and variable a at all. It doesn't matter. You can write it as I also, this I and that I, they are completely different from each other. There is no relationship between them. So if you put I here, also it doesn't matter. This I, so the I here and the I here, they don't have any relationship. All right. So next comes, yeah, you can return A star A without using. I wanted to illustrate a point because of that we are doing. So you have learned about functions. Yeah, one variable in one function is completely independent of variable in another function. Okay. So now comes some next cool idea. So you have learned about functions and you want to write your programs. Srija has this question. See, some of you should, don't worry, you should send it to everyone. So that your question itself gives interesting answers. In the previous example, the variable squared underscore value is in the memory of square function S. That is the question asked by one of your buddies. And when we return squared underscore value, whatever is in that variable in the squared underscore value is copied to the main function, copied or returned to the main function. That's true. That is true. So here now I will introduce a puzzle to you and then we will solve this problem in the next class, because I'm sure some of your classmates would be feeling a bit difficult in following. So yeah, what's the story? Yeah, so you learned about functions, so you want to write code which is very nicely organized. So you want to write a function for reading read value n, so which reads a value. So what do you do? So you go here and so there is this thing variable n. So we are writing this print value n, and then I have this dummy thing compute value n. So you are reading the variable n, you are reading the variable n. Yeah. So void read value int n. Okay. So printf enter n. So you want to write modular code ampersand n. Okay. So compute. So here, print value n. So okay. I think I made some mistakes. forget about something. This compute value n, we are not doing anything for the time being. You can just. So now, when you compile this program and run, what do you think will happen? Let's compile this program. GCC CP21A. So GCC read var.c. So if I enter 10, what will be the line that what will be printed on the screen? What will be printed on the screen? Random number. Huh? Why random number? Ten, 10. Okay. It is printing some 0 actually. It can be random also. So it's not printing 10 at least. It can be anything. It is 0, but it can be anything. Why it is 0, I have some hunch, but it can be anything. Okay, so last 5 minutes, we will conclude now. We will pay attention. I want you to think about it. So what did we say? That this is the, no, compiler doesn't change it to 0. Compiler doesn't know whether a value is garbage or not to start with. So here, this is the function main. This is the function main. In the function main, let's say this is the memory as allocated for n. Okay, this is main. And then what is happening in main, we are calling the read value function. This is the read value function. This is the read value. And this is the memory allocated for n. This is the memory allocated for n. So when we call main with on line number 18, let's say n contains some garbage value 3457. So what happens is this value gets copied into here when we call read value function. And then in read value, we are doing a scanf, and let's say the value that we have entered is 10. So what happens is this gets overwritten and we write 10. And after that, when we come back to the main function and when we print, so when we modify it to n, whether the value variable n in the main function gets modified. In read value, when we modify n, does its value in the main gets modified? No, no. So it's not going to affect. So when you come back and you print value, no, there is no link between this and this, no link. Okay. So because of that, whatever the value that we are reading into variable n, if we are reading into the parameter n, it's not affecting the variable n in the main memory. But we want this functionality. No? We want this functionality. What is the functionality that we want? We want the functionality that we write a function to nicely read the input that we want. How do we solve this problem? Return n is one. Very good, Srija. Divij, good. So we use pointers. So we will learn pointers in the next class. That's all for today. In the next class, we will study pointers. And I would say we are all cruising at a super good speed. And after you learn pointers in the next couple of classes, you know, pretty much everything that you need to know about C is gone. Okay. So that means you have learned C programming language in the first 3 weeks of your course, and the rest of the time you solve nice problems, not worry so much about these things. Okay, How do you do printf? How do you do scanf and all that stuff? And all nice problems, more and more nice problems we will solve as we progress through the semester. But pretty much by the next of semester, sorry, by next week, you'll all be good. All important ideas will be what other languages. I will stop. Let's do one thing. I will stop recording.